The tech person of the week that I picked is Manny Medina. He is the CEO of Outreach. It's one of the largest sales engagement platforms. What sales engagement is, it's very businessy, but just like high level. It's just a way for companies like a way for people to work on how to engage with their buyers and how to like develop that relationship. So that's what that company does. But the reason I picked him is he has a very inspirational story, and I thought he'd be a really good person to highlight. He was born in Ecuador and then came over to the US because he thought there would be better opportunities, and then got his master's in computer science, and then his master's in computer science from UPenn, and then got his MBA at Harvard. One point that he said at one point that I thought was really inspirational is when he came over, he had an accent, and he really wanted to work through and break the barriers of people associating someone with an accent with someone who isn't necessarily educated. So that's why getting his master's in computer science and applying the tech that he knew and then the business that he learned from Harvard into starting a company that's really successful, like Outreach. So I thought it was a really good story of how like he kind of conquered those barriers, and then also how he took his tech background and made it work for something entrepreneurial. All right, I can stop sharing my screen now.
Sweet. All right, so I'm gonna start off just quickly with AR and how it works. So it's from like a very abstract view, it's computer vision. Everything's like pretty much abstracted from us. So it's based off the idea of having access to the camera and being able to tell between different frames in the video, like the difference between visually distinct points, like points that have like different colors from like the surrounding pixels, and then like with that parallax, finding computing like the estimated position of the device and how much it's like maybe moved over time. All this is like made faster and easier with the inclusion of like LiDAR systems. So because they don't have to use like just the camera data, and they especially work better at night. And it just allows like the device to get a sense of the environment with the inclusion of the LiDAR depth data. Yeah, so we're gonna like go through some examples. So Angelina or Brendan, if you.
Sure. So there are a lot of great applications of AR in the real world. Some of them are very useful and others are just interesting and fun. So everything from a video game like Pokemon Go, which I'm sure many of you are familiar with from a couple years ago, to Google Live View, which is a new feature in Google Maps, to IKEA Place, which is an app for placing furniture in a real space, but placing the furniture digitally, as well as Doodle Lens, and then a related application of how autonomous vehicles work. It's also related to AR. So we have a video of Live View on Google Pixel.
So yeah, what's happening right now is it's like taking a short video clip and then like sending that to Google, and it gets back like the relative position and then the directions like overlaid. So yeah.
And we also have a video demonstrating IKEA Place, so you can see a real space in which the user will place digital furniture, and then they can see how it looks.
So this is less dependent on like the actual environment. This is just like you don't have to scan your house, or just like place it right there. Yeah.
And we also have a cool Assemble AR link as well. So Samo, when this video is finished, if you could click that to demonstrate another application, also IKEA, but more interesting. If you've ever had trouble assembling IKEA furniture, then this app might be interesting. It helps you assemble the furniture by giving you a visual walkthrough. Generally, AR can be used to show the user a lot of interesting things, display information in novel ways, or just present a solution to a problem in a different way than one might be able to with just written instructions or pictures. By overlaying on the environment, you can get another layer of complexity and detail that helps the user navigate.
Yeah, especially since our phones are usually just used for like scrolling through like just text and images, like getting a 3D sense is like really helpful. Cool.
And we have one last video of a game being played in AR, and then we're going to move on to explaining how AR works behind the scenes and the data structures in place. So Sama, if you go to the next slide.
Oh, sounds good.
Or, oh, Vincent, screen sharing it. Thank you, Vincent.
Yeah, this is showing like the possibility of having multiple people see the same AR content. So there's actually like 3 devices hooked up to this. And they're all like playing a game where the goal is to knock down like the different like pins, like these little slingshots. So.
It's so crazy that someone's playing this game. Like watching someone, imagine like watching these people play this game when you like can't see what they're seeing. Like they must look crazy.
Yeah, only that other person with the 3rd iPad can really, yeah, so it's pretty funny.
All right.
So this is actually like an app that I'm working on. It's called Inventory. The idea is to be able to like scan your house and then like it being able to do like the Google Maps thing where you take like a short clip of video and then it matches it to the point, like the point cloud that they have of like all the buildings. But instead this is like in your house. And then you can like have different items sort of like tracked there in the app. And then you could just pull out your phone and take like a short clip of like, just pull out your phone, point it at like some furniture, and then it recognizes like, this is where I am in your house, and like, this is where something useful is. And then like, the idea is to eventually have it so that you can share that like database and like have maybe like your dog sitter know like where all the dog related items are. So yeah. And then this is just like the way the scanning works is it's powered by AR in terms of like being able to localize and like know like where it is, and then it uses LiDAR as well to take the scan. So it's all like a whole bunch of points, and then you can save it, and then it uploads it to the cloud and then populates, and then you can look at the 3D model of the points.
Sumina asked what LiDAR is.
So LiDAR is basically infrared light that, so the way it just measures the time between when it like shoots out the light and then when it gets like some of it back in the sensor. And depending on like how quick that is, it can determine like how far away that like object is like from that point in the camera. So yeah. So here's like the general structure for like how we set up an AR scene. So, which is like our view. So we have a session and like all those sessions have like different frames that are like that current point in time. You also have your configuration, which like can tell if you want to have it generally be like mapping the world or just like placing content. Or you could have like different like settings to show certain like useful things, like the points if you wanted to, or like what it thinks is the position of like when you first open the app, as well as like, so everything is attached to an anchor. So anchors, there are multiple kinds of anchors. You could have it be a plain anchor, or you could have like an image. So that content that you add to the anchor is like set there in like real life. And so if you move your phone, the content stays attached relative to that anchor. So, and then you can also have like multiple like models. So those are like our 3D models that are attached to the anchor. So all of this like isn't actually displayed. This is just the structure. So this is the view actually implements like what we actually see from the entire AR session. So again, we have LiDAR or our just visual data, and then it gathers where it thinks you are, and then your origin point, like the world origin. So like in math, the 0 point is where you start off with AR. So when you just like press the AR button, wherever your phone is, that's where the origin is. So it's really useful for trying to figure out like if I want to place this content somewhere, like it's relative to where you first began. So again, you can have like, there are multiple types of anchors. There are actually anchors now for like people. So it figures out like the pose of a person. So like literally like how where their arms are, and then it can attach certain things to like their hands or their head. So it's really cool like that. Definitely relying on a lot of like computer vision, machine learning algorithms but it's all like abstracted for us if we use those anchors. So this is just a little Swift playground. So everything that we're doing here is in Apple's AR kit. It's really nice in the way it's like abstracted. So this is just like some Swift code, and you can see just the world origin and like the feature points, which are like the distinct points. So the green, red, and blue lines, like where they intersect, is the world origin. And then there's like all the points down there, sort of like against the weight of the chair and like the black sort of, so yeah, they're kind of hard to see with like, but trust me, they're there. So again, just like important to reiterate like that we have anchors that are, that we attach the content to. So you can also like move those anchors, and when you move those anchors, all the content just like moves with it, which is like important just to reiterate. Yeah, so this is like some code if we want to actually add something. So this is just a blue cube. You can see here that we first have to like make the view and then like add the model. So we construct the model with like a material. In this case, we're using like blue, made it metallic just because. And then you can add that to the anchor, and then set it to the actual session, and then you get something that's like attached there. So yeah, super simple, totally abstracted. Just the only things that to like mess with are like how large the box is, or like just the material on it. You can like do different models that are built in as well really easily. So again, like building off how it works behind the scenes, it's all based off this idea of SLAM, which is simultaneously localizing and mapping. So again, like figuring out where you are, and then like getting like using that parallax effect. and figuring out sort of like your position. This is also like used in autonomous vehicles with like Tesla. They have like 7 cameras. They don't actually use LiDAR. They just like use the camera. So like you don't need LiDAR for it to be a good experience. Like again, like everything you do with like AR can be changed drastically by like what engine you're using. So like you can have like a lot higher quality visual content if you like use like Unity or Unreal. Those are like typical game engines, and you can like get some really professional looking content displayed in your space. So this is another app I was working on. Basically the same premise of inventory, but it was like using images. So you have like you tell like the system what images are for what space, and then relative to that image, like where different items in your house or wherever are, and then you can like have it display those positions. So this is like it showing like where the printer is, but it could be like a little bit further away. It's not like a great, doesn't really scale for like really big spaces, because like the slight angle of the picture on the wall could like mess it up for like if you're 100 feet away. So, but definitely was a start. So cool. So this is like code that I wrote a year ago. So it's not the best quality in terms of like the use of the language, because I was pretty new to using Swift, which everything here is in Swift. That, albeit it's like still, we're trying to see like if the anchor is an image anchor. We're like trying to get trying to overlay like the position of like the spheres, like have that be moved to like the position where it should be, using like what's in the database as well. So here is like actually where it like gets the position of like the printer in this case, and then it draws like a transition between it having 2 separate balls, 2 separate spheres, that one is like moving towards it over like a time frame that's dependent on like how large the distance is. So that's where the little math comes in. But yeah, so I'm just gonna leave it with just like another example of the crazy powers you can have using AR. So here's cat. This actually went viral on Twitter, and yeah, just like a cool use of like both like computer vision, like machine learning, like detecting like the difference between the cat and then overlaying it in AR. So I think, and I believe that's one of the dual lens app that we included in the slides before. So yeah. So now we're just going to leave it open to like a Q&A. If you have any questions, I could probably dive in and yeah, explain it to you. Because again, like live demos are not like a good way of like really learning this, because a lot can go wrong with like debugging, especially AR code. Yeah, but
I have 2 questions.
Awesome.
First question is, you probably like are, I don't know if you're gonna do any like, if someone like wants to jump into AR, like where's a good place to start? I don't know if you like have resources for after.
Yeah, I think there's like, so,
okay, we can get to that.
So yeah, so there's I learned a lot from like this YouTuber developer, Ryan Kopinski. Really great like videos that like really show like what you can do with AR, and explains it like really well and super clearly. yeah, there's that. And of course, like there's the just documentation that's like kind of dry to like read and like go through. But yeah, so there's a lot of different ways. There's also like a lot of blog posts, and if you're like into that, you can read, but like I've definitely read a lot. But if you want to have like a more visual like view of it, definitely check out Brian's channel. It's very well thought out, and yeah.
I just looked him up. I'm gonna watch after. My other question is more like directly to you. What made you want to do like AR specifically as opposed to like any other part of CS or like skill in CS that you could pick up?
So I really I really like math and like CS, and then I'm just like, well, if I want to like combine everything I know about like math, maybe AR is like a great place to like, and computer vision in general, is to like use sort of like what I've learned in math and like apply it. And so yeah, that's why I'm personally a combined CS and math major. And yeah, AR is just like super fun because you get to like see like your code in a different way than just like, because it's like 3D and sort of like maps onto your world, and it like, especially as like technology advances, I think it's going to be really, really cool to be a developer and be doing this stuff. Yeah.
Oh yeah, I have a question. Because you're like super talented, you're really good at like math, like CS and like design. I was wondering how how much math do you think you should know, and like how intensive like do you think it will get, like AR will like get?
Yeah, so yeah, it's kind of like daunting at first because honestly I didn't know so much of like linear algebra and stuff, like trying to figure out positions and like the orientations. It gets like kind of scary, but and I think like there should be like right now there isn't as much abstraction of that as there like could be. It's kind of like so you really have to learn about how like positions are represented, especially because it's not just like XYZ, it's also like the pitch, the yaw, like all those different orientation aspects as well. So I think like you can definitely personally I don't even like have like a full grasp of it. It's more just like a sense of, okay, like I can get this position relative to the other by taking like the inverse of the matrix and then let's find it together thing. But yeah, so you can definitely get a long way just by using like built-in like methods that are less that are more abstract than just using like positions and stuff in matrices. But yeah, it does get a little much. But yeah.
A quick question. Do you think there's kind of any kind of overlap between VR and AR? Or do they kind of live in separate realms? I guess, I mean, there's some overlap in terms of like the math and stuff like that. But do you think like, if you were interested in like VR, would it be easy to kind of transfer over the skills between VR and AR, at least like in terms of like the development and stuff like that?
Yeah, I think of AR as like a superset like of VR, and MR. MR is sort of just like mixed reality. So mixed reality is just like, I guess like kind of having a bit more inclusion of the world than VR, but not as much as like AR. So like everything that you do in VR like still applies in AR, except that you have like different positions to worry about in like space and how you attach things and yeah. So if you're interested in like VR, it shouldn't be too hard to like yeah. There's so much overlap and like everything. It just depends on like what different software you're using, different frameworks, because like if you want to integrate like Unity, like that's, or like Unreal, I'm not sure which engine is like preferred in like VR, but like you could totally bring that to AR and see it working. So yeah.
Vincent, I was wondering, like, do you know of any, like, which math classes do you think are like most helpful to take if you want to get into AR? Like,
so definitely linear algebra. Yeah, knowing like a lot about matrices and like how to represent like positions and like just knowing like how space is like represented in math is like very like helpful. Yeah, and right now like the class I'm taking DPQ and linear algebra, so it's like combined in a sense. But so yeah, definitely linear algebra.
Is testing the code you write and what you're working on with I was about to say VR, AR, difficult?
Yeah, testing is kind of interesting because you can actually like, you can have different like video clips recorded, and then like using those video clips, you can like bring it back to your computer and have it like run the code like through it. Sorry, but yeah, it's kind of like different in terms of like testing any other software because it's very dependent on like the camera's input and like position from like data from like the phone or the like the accelerometer, like knowing what direction it's moving in, stuff like that. So but like the other like your other things that are dependent, I mean, I don't know if like you don't usually like test your model, so that usually you can just view it in like if you're making some sort of cool game, you can just like look at the models directly. You're just not so much testing that like it actually shows up. It's more just like you can do it after the fact. You can't really do it just run like something in GitHub and have all your tests pass. It's, yeah, definitely a more hands-on thing.
Vincent, I'm wondering about what the debugging experience is like working with Swift, because I know you've used Swift AI and Swift relative to ARKit stuff. What has the experience been like? Is there good support online? Is there a good debugger built into Xcode? Do you use Xcode? Like, what is the developing experience like coming from somebody who hasn't had formal education in Swift and has just tried to figure it out yourself? And
Yeah,
what was your trajectory?
Swift is like it's like a great language in terms of like having things have types, and you if you know how to use the features of the language, it's really hard to get code that like just crashes. That it can like be wrong in like certain ways that are kind of mysterious if you're using like mutation stuff like that. But nothing that's gonna, because everything can be defined. Everything can be like optional or the value itself. You define that in your code. Like question marks denote whether something is like either the equivalent of null, which is nil in Swift. So in terms of like, it's kind of like a better language than like say Java, where you have to like say, oh, if this is null, then like throw some exception or something. Because like you know ahead of time, like you know it's actually the type of that thing. So you typically like don't have all those, have to do so much debugging, because you can optionally unwrap something. So if something's nil, then just don't run this code. And it's like you don't have to write it like if it's null or something like that. You just do like if let. There's all these different sort of features in the language that make it like easier to deal with like typical things that would sort of you spend your time debugging in Java or yeah.
Cool. Along the same line of thinking, how much of the functionality did you have to handle yourself versus the stuff that's handled by SwiftUI and ARKit? Because I know that Apple made a bunch of things to make it easier for you, but you still have to handle a good amount of stuff yourself. So what kind of things did you have to do versus what was handled for you? And was the stuff that you had to do mostly like configuring and piecing things together?
So I think like SwiftUI is a really great way to sort of abstract like what would normally be like so much more work in terms of and like the code you would normally write would like in Java would be a lot more dependent on like it's not nearly as like declarative, which means like you write something and it's sort of like if you ever use CSS, like so like having like your website look a certain way and like depending on what browser you're using, it just sort of like decides what it looks like. But you definitely have to just give like the basic premise of what you want. So like what you want to show, and then of course like handle like your data representation, like what is in this case like what's a space and what like how does it have items and how can I get those items and how can I get their positions. Like you still have to do all that. Yeah, but it's definitely like easier to make apps in SwiftUI specifically. But there's also like different, I know like the language Kotlin, which is like a superset of Java. So it has like everything in Java, but like it's typed better. So it has like the benefits of Swift, and as well, it's also, so in Funnies 1, we learned about functional programming. So Swift has functional programming, and so does Kotlin. So you don't have to worry about mutation. You just have like you have those types be static, and yeah, so you don't get like those weird issues down the line, and you have to like test a lot to figure out what's going on. Yeah.
Do you think we live in a simulation?
Why not? Honestly, with Corona, should be. Honestly, yeah.
Yes.
Cool. How Musk of me, no.
Vincent, I was wondering, like, can you talk about the overall like design or like structure of the code, or I don't know if you like.
Yeah, I can like actually show, yeah, some code. I can like quickly.
Would you describe it as like object oriented?
So the weird thing is, like the code I'm actually writing is like a combination of object oriented and functional programming. So I'm gonna stop sharing my screen and then like get the Xcode fired up. But yeah, so your views are all functional, but then like your data representation is usually object oriented. So
and
yeah.
Does Swift have like, I know Kotlin has like data classes, so it's like it automatically creates like getters and stuff like that, and all like kind of the default stuff for you. That way you don't have to like, and like also constructors and stuff like that. But
yeah, so Swift, you can still there's you can have it automatically make constructors and initializers for classes. So structs are just like automatic have their initializers. You can add multiple, you can add like new ones too on your own. Yeah, so let me see. Just gonna quickly see what part of my code is like pretty cool to show.
Could you say Swift is something that Dr. Rackett wanted to be but couldn't?
Yeah, I think Swift is like so many different ideas like thrown together. Like,
I'm joking,
but
by the way.
yeah, Dr. Rackett.
I want to stand up for
List.
Dr. Rackett here, though. Dr. Rackett knows what it's doing, and it exists. It's not the best language, but it certainly exists, and it knows what it's doing.
Yeah, Common Lisp, it has its place. But yeah. So let me see. Okay, so cool. I'll just share this. So this is like, let me see. So Siri. So you have, this is like a view to edit what the name of the space is. So it has like a scroll view, and then like you tell it like, I want like a horizontal stack between having a name and then a text field. Again, it's like very declarative, but all these like everything. So this is a struct, so this is like functional programming, but then you have references to objects. So yeah, so the data is a class, and then it's an observed object. So that means these property wrappers, like they say, if this object changes, notify me so I can like refresh the view. So yeah, and then like state is like you add your own object, and then dependent, like if that's changed, like it reflects in the entire view. Yeah. So
Vincent, it would be helpful if you could increase your text size a little bit, because I have a fairly large screen and I still am having a bit of trouble reading. Thank you.
Cool.
What color theme are you using? This is very magical looking.
It's the default.
Oh, really?
Yeah, I don't know. I like the purple. It's very, yeah, it's cool. Yeah, there's like definitely code that's like scarier than other parts of it. You definitely, so everything is like separated out in terms of like different views. You definitely want to make more components, yeah, and just like sort of bring them all together in your, the way it works is your app delegate. So you load your view, I think, yeah. So yeah, that's where, like, this is the main view. Everything else like sort of like lives inside of it. It's like called between like, yeah. Yeah. So like these things like have different logic depending on like what platform you're using, whether it's like if you're trying to run it on a Mac or an iPad or a phone, you can sort of like specify that. Yeah. So is that like,
yeah, so you answered my question, but I'm just wondering, what's the like the inventory tests and like the inventory UI tests?
So I like have not made that many tests for this, which is like definitely very bad practice. Like I definitely like if you go here, like there's literally no tests. So yeah, this is like something I've been working a lot on, but I haven't actually tested, which is very bad. Very, very like Amal would not be proud. Yeah, no one would be proud of me. But so like the thing is, I'm not doing that much. So everything that I'm doing like is actually being uploaded to the cloud, and then I can just like look at. So AWS has their console, and you can like look at like the actual data itself, which is really cool. Usually I just, yeah, I've been using like breakpoints and stuff, but I definitely should be testing and like taking advantage of things that are Swift. But yeah.
All those style points.
All those style points. Yeah, so cool. Hopefully that answers a lot.
I guess, well, if you guys have more questions, feel free to just like put those in the chat or just ask them. I could pull up the feedback form.
And especially with like computer vision stuff, which is more machine learning, it's like definitely a lot harder to like test that kind of stuff. Yeah, it's really dependent on your data, which is why like it shouldn't really be applied to very important things. But yeah, in my view, except like if you're like facial recognition, for example. Yeah.
Yep. Perfect. That was really cool. I learned so much. And again, we have more time for questions. If you guys want to stick around and ask more questions, I feel like this is just a big AR delving into like something that I really didn't know that much about session. But next week is our final meeting. It's just going to be a chill meeting. You can come hang out with us. We're going to talk about if we have any roles open, if you want to apply, we'll let you guys know, and then we'll send that out. And then, yeah, just come hang out with us, take a break. We might do games. We'll let you know. I really wanted to do Among Us this whole time. Last time we played it, I had so much fun. So you might set some time aside during that meeting for that. But just come hang out and take a break from your projects or exams. December 9th, 6, 7, same time. And this was an amazing presentation. Thank you so much for all the information on AR. We'd love to hear your guys' feedback, so fill out the feedback form here. You can either use the bit.ly link or the QR code. I'll leave it up for a couple minutes, and then you guys can continue asking questions also.
So I think like a main takeaway is that like AR can be a lot more than just like placing furniture. Yeah, there's like definitely a lot more stuff to sort of like get your hands dirty with and like see, and there's definitely a lot more to explore, like if you're really interested about like computer vision and like sort of like figuring out really complex problems and like sort of like bringing them and overlaying them in the world. And like, yeah, so for example, like there's apps like to see like what species like a plant is, and like that's done in AR too. You can have that like overlaid. So there's definitely like so much that you can do that's like, yeah, so much more than like what's currently out there. But yeah.
I think it's really cool that you guys made AR seem more, developing AR seem more accessible than it was, because I didn't realize that you could just write AR code in Xcode. So I thought that was really cool.
Oh yeah, you could do it like direct, if you have an iPad, you can do it right there in a Swift Playground and just like see it right there. If you have a Mac, you can open a Swift Playground, or you could have like an app and then just like put it right on your phone. Of course, like I don't know much about AR Core, but from Google, but I'm sure it's like just the same sort of level of abstraction, and yeah, super easy to start working with.
All right, we should probably conclude because Vincent has an exam immediately following this meeting. Thank you all for coming. Hope to see you in our next meeting. It's going to be fun. Hopefully just do some relaxed multi-meeting stuff. Yeah, thank you all for coming. Have a good night.